Hi, this is Dr. Xu teaching mine ventilation for mining engineering college students. In this video, we will talk about psychrometry and the use of psychrometric chart. So the working environment temperature and humidity impact the level of work comfort. Generally speaking, below 25 wet bulb temperature, there is minimum thermal discomfort. As the temperature increases, the thermal discomfort level will also increase. Working under very hot conditions will cause various heat illnesses, including heat stroke. Study has also shown that workers' production rate decreases with the increase of working environment temperature. Therefore, it is important to know how the temperature of air changes with other properties of air. Fresh dry air is a mixture of gases in relatively constant proportions with 20.95% of oxygen, 28.09% of nitrogen, and 0.93% of argon, and a little bit of carbon dioxide, about 0.03%. Air also contains water vapor, commonly referred to as humidity or moisture content. Psychrometry provides the means of quantifying sources of heat from survey data or predicting air temperatures when sources of heat are known. The mathematical description of the properties of water and air mixtures is known as psychrometry. So air mixtures contain dry air and water vapor. Psychrometry equations are used to calculate properties of air mixture, including the heat content, the enthalpy and sigma heat, the true density of the mixture, and the moisture content of the mixture, and the mass of dry air per cubic meter of water vapor air mixture. If we know the dry bulb temperature, wet bulb temperature, and the absolute pressure of air mixture, we can use the equations listed on this slide to calculate the psychrometric properties of air mixture. So we will need dry bulb temperature. It is the dry bulb temperature in Kelvin. The conversion from Celsius degree to Kelvin is Kelvin equals to Celsius plus 273.15. Celsius or Fahrenheit temperature are normally measured in a ventilation survey. Make sure you convert it to Kelvin temperature in the psychrometric calculation. The dry bulb temperature is the value quoted by weather forecasts. In weather forecast, if the temperature is 25 degrees, this is the dry bulb temperature. The wet bulb temperature is measured by the wet sock thermometer in the sling psychrometer. The wet sock loses heat due to evaporation in the aspiration process. So it measures the effect of evaporation rate, which is directly related to moisture content. The absolute pressure of air is measured using a barometer. One standard atmosphere pressure equals to 101.325 Pascal. The pressure changes with depth, and also the fan causes pressure change in the mine. Let me briefly introduce some of the other psychrometry properties of air. They are related to mass of dry air because it remains constant. Apparent specific volume ASV is the volume of air mixture per kilogram of dry air. Air mixture V air is dry air plus water vapor. Apparent specific humidity ASH is the gram of water per kilogram of dry air. Enthalpy is the heat content of the thermodynamic system. It consists of the internal energy of the system U plus the product of pressure and volume of the system. Enthalpy of air mixture equals to enthalpy of dry air plus enthalpy of water vapor. Enthalpy of dry air equals to air thermal capacity by dry bulb temperature of air. So if the dry bulb temperature of air is measured, its dry air enthalpy can be calculated. Enthalpy of water vapor equals to sensible heat of water vapor plus latent heat of water vapor. The sensible heat is the heat that changes the temperature of the water vapor, and the latent heat is heat required to change the water from liquid to vapor. Sigma heat equals to enthalpy of air mixture minus sensible heat of water vapor. Sigma heat is proportional to the wet ball temperature. Look at these psychrometric equations again. Using wet ball temperature, dry ball temperature, and absolute pressure as input. See here, wet ball temperature, dry ball temperature, and pressure. You can make an Excel sheet to calculate the values listed on the slides. So these values can all be calculated by using the wet ball temperature, dry ball temperature, and pressure. We can also make a psychrometric chart using the relationship of the psychrometric equations. This is sometimes convenient for quick calculation and references. As we talked about before, we need 3 basic parameters to find other psychrometric properties. What are they? Yes, they are absolute pressure, wet ball temperature, and dry ball temperature. The psychrometric chart is made for a specific absolute pressure. This chart is for 100 kilopascal of pressure. Once the absolute pressure of air is known, make sure you use the corresponding psychrometric chart for that pressure. Next, we need to know dry ball temperature and wet ball temperature. The dry ball temperature is here, from 0 degree to 60. And it's corresponding to the lines in parallel with the blue line. So these lines here. So these lines here. So these lines here. Assume the measured dry ball temperature is 30 degrees. We can mark it here and draw a line as the blue line. The wet ball temperature scale is here. So along the curved lines. So here is 0 degree, 5, 10, 15, 25, and the lines are these lines. Okay, so if the wet ball temperature is 26, at the 26 scale place, we can draw a line at the red line. The yellow dot here is the intersection of the dry ball and wet ball temperature line. So the blue line and the red line, the intersection is the yellow dot. From here, we can read off other values. For example, the apparent specific humidity scale is here. So 0, 5, 10, 15. And the lines are the horizontal lines. If we draw a horizontal line from the yellow dot to the apparent specific humidity scale, we can read it off. The apparent specific humidity is 20 grams per kilogram. The apparent specific volume here, the lines are these lines. And the scales are here. This is 0.8, 0.85, 0.9, 0.95, and 1. If we draw a line in parallel with the apparent specific volume lines from the yellow dot here, we can see this value is between 0.85 and 0.9, and it is slightly less than 0.9, so the value is 0.89 cubic meter per kilogram. The relative humidity scales are here, 10%, 20%, and the lines are the curved lines here. From the position of the yellow dot, we can see that the relative humidity is 70%. So this is 50%, 60%, and 70%. The sigma heat scale is here. So from 0 to 140. The lines are the same with the wet ball temperature lines. So the lines are these lines as well. So they are the lines in parallel with the red line. To find the value, we just need to read off the value from the intersection of the red line and the sigma heat scale here. We can see that it is slightly lower than 80, and we can read it off more accurately as 78.8 kilojoule per kilogram. The vapor pressure scales are here from 0 to 7. And the lines are the horizontal lines. If we draw a horizontal line from the yellow dot from there all the way to there, we can see the vapor pressure is about 3.11 kilopascal. The enthalpy scale are here from 0, 10, 20, all the way to 120 and 200. The same scale is repeated here. So we can read off the current air enthalpy extending this line. It's about 80 kilojoule per kilogram. Psychrometric chart may not look all the same, but the fundamental principles are all the same. You firstly need to know what pressure that chart applies to. Find where the dry ball and wet ball scale and lines are, and find the scale and lines for the other parameters. To sum it up, in this video we have introduced the psychrometric property of air and the equations to calculate these properties, as well as read them off from a psychrometric chart. Thank you very much for watching. This is Dr. Xu. I will see you in the next video.